We'll focus this video actually how to graph of a polynomial function. So we see the graph, how to draw graph of a polynomial function. So to draw the graph of a polynomial function, we need to first calculate a few things. So that let me list first here. So firstly, that we check if you have a polynomial. First we check the AND behavior, and then we calculate so the x-intercept, you can say the intercept, where we calculate x-intercept and y-intercept. So two intersect we calculate x-intercept, that sometime called the zero of polynomial, and then we calculate the y-intercept. So basically we will focus these two things when we calculate the graph of a polynomial function. So let's start with the example. So here it is. Draw the graph of the polynomial function. Say it is given by fx equal to x plus 1. So let me take in the factor form, and then x minus 2 whole square into x plus 3. Okay, one thing I forget to tell you here, that it is also important that sometime needed. So this is called the possible number of turning point, or you can say the number of turning point, number of turning point. So when we calculate the graph of a polynomial function, we always keep this three thing in mind. So first we check the AND behavior, then we calculate the x-intercept and number of turning point. This number of turning point is not too much important, but still we see. So let me write here that if degree, so about the turning point, if degree of a polynomial f is n, then so it has, so then graph has, of course the graph of f has at most n minus 1 turning point. So this actually very much important. This is at most we can have n minus 1 turning points. For example, if the degree of the graph is 3, then it can have at most 2 turning point. So this mean at most mean it cannot have more than n minus 1 turning point. So let's see this example. So firstly we calculate the AND behavior. So here it is. See, when we calculate the AND behavior, first we have to find out the leading term of the polynomial. So your polynomial is fx equals to x plus 1, x minus 2 whole square, and then x plus 3. So if we want to calculate the AND behavior, firstly we have to calculate the leading term. So let me write here the leading term. Leading term this equals to here, take the leading term from here. Okay, one thing I tell you here, so let me write here for this one, the leading term of this here, since you have a x plus 1 to the power 1, so leading term in highest power of this expression, so it will be x, and then into the leading term of this, it is degree 2. If you expand it, you get x square here, so let me put here x square, and this is degree 1, so then again you get here x. So if you product, then you get x to the power 4. So the leading term is x to the power 4. Now let me tell you the situation. If you have here, instead of having this situation, if you have something like this, let's say your polynomial minus 2 of x minus 1, x plus 1 whole to the power 1 into x minus 2 whole square into x plus 3. If your polynomial is this, then the leading term will be, in this case, you have to take this minus 2, and then rest will be the same. From this you can get x, then from here you get x square, from here you get x. So total, the leading term will be 2x to the power 4. So basically I am trying to say here that if you have something before the the factor, or if you factor polynomial, and if you have something before the factorization, that you have to take in the leading term, so that you have to care, so when calculating the leading term. So in our situation, the leading term is simply x to the power 4. So this is our leading term here, so the x to the power 4, and leading term actually calculates the end behavior of the function. So let me make a table, so let me check you the how the end will change for the graph when you go to the very much right hand side of along x-axis, and what happen if you go very much far from origin toward the left hand side. So let me make it is here a table. So here we take if, so right hand side, when you calculate, you have to put x equal to infinity. So put x equals to infinity, just normally let me write down here, then you understand, in x to the power 4. So then what we get infinity to the power 4, and infinity to the power 4 mean infinity into infinity into infinity into infinity, 4 time infinity we have here. So we get, so infinity into infinity, so this is nothing but the infinity. So this means, this we write mathematically, so that the polynomial fx tends to infinity as x tends to infinity, because since leading term gives infinity, so the whole polynomial will goes to infinity, of course, when we taking x tend to infinity. So this is the right hand behavior. So what happened the left hand, if we check, so left side behavior. So for the case left side, we have to put x equal to negative infinity in the expression x to the power 4. Then what we get here fx, okay, firstly we have to check what we get. If you put negative infinity in the place of x, then it is negative infinity into negative infinity into negative infinity into negative infinity. You can use the parenthesis because of negative here. So then you get negative infinity into negative infinity is infinity. So the same thing we are taking that we did for numbers. The product of two number, positive negative number will give you positive number. Here product of two negative quantity give you a huge positive quantity. So this is nothing but the infinity. So we get that the function goes to infinity as x goes to minus infinity. Sometimes people used to say that this situation, the function graph, the graph goes upward because x goes to infinity, so upward. Instead of having x goes to infinity, if you have fx goes to minus infinity, then you have to write here graph goes downward as x goes to infinity. Similarly, here people write like this, the graph goes upward because fx goes to infinity as x goes to negative infinity. So sometimes people do like this, this way. Sometimes people this way too. Right now, what we see here basically that so this is the AND behavior. Now the thing we have to do here basically the next is the intercept or the zero. So let's calculate the zeros here. So the intercept. So here in the intercept we take x-intercept, that sometime called the zero. So the zero of the polynomial. So if we do it here, so what we get, so look at the polynomial whatever you have, fx equal to, of course since we have here the polynomial in the factor form, so if you have polynomial not in the factor form, first you have to convert it into the factor form, then everything you have to do. So what it will be x plus so okay, in the factor form we have here this and x minus 2 then whole square then x plus 3 whole to the power 1. So how you calculate x-intercept? Make every factor 0. So from here you get x equal to -1 and x minus 2 equal to 0. From here we get x equal to 2. For the last factor x plus 3, that will give you x equal to -3. So what we are getting, the graph intersect, the graph intersect at the point all right, the x-axis, the graph intercept x-axis at the point -1, 0, 2, 0 and -3, 0. So sometimes people used to say that the x-intercept are -1, 2 and -3. But while you doing the graph, if you say the graph passing intersect the x-axis at that point, so then you know one thing clear, that the point where the graph cross the x-axis. So that is clear. So anyway, so you can use either that you want. So now we see the y-intercept here. So this is basically give us a information about the graph where the cross the y-axis. So that we see here. The only one way always we do this, put x equal to 0. We get, if we put x equal to 0 in the expression, then we get say f of 0. We are interested to calculate 0 plus 1 whole to the power 1. This expression we put, x equal to 0 and then 0 minus 2 whole square into 0 plus 3 whole to the power 1 and this. So we are getting here 1 into 4 into 3, so we are getting 12. So the graph, so y-intercept is 12. So graph passes through y-axis at the point 0, 12. So the graph passing through this point. So this three information very much important when you want to draw the graph of a polynomial function: the AND behavior and x-intercept and y-intercept. Of course the number of turning point is important, so let me write down here the turning point. So if we know the information that how much turning point we have, so then it is good for us. Later the turning point, you say the when we calculate the when we use the calculus, we say this is the the something called the where the derivative becomes 0, so that is a settle point. So then we see. So basically now let me write down here the turning point. So how many turning point the polynomial function have? Since degree of f, So degree of f is here. So how we calculate degree? Look at the polynomial. So from here we have degree 1 because power 1 we have. Here we have degree 2, here we have degree 1. So total degree will be of is given by 1 plus 2 plus 1. So basically 4. Otherwise you can, not doing like this. Why 4 we getting? Because of the leading term power will be the degree. So this one you can use because already you calculated the leading term. Here the leading term is this. So this power will be the degree of the polynomial. So this is the degree. So the graph has at most 4 minus 1 equals to 3 turning point. So that is very much important. So there are at most 3 turning points. So this means there is no more than 3 turning points. So that is this information sometime we need when we draw the graph. How many band it has like that. So let me draw here graph now. So firstly we need a x-axis and we need so let me draw here the x-axis and we need the y-axis like that. So now what we do here, so basically okay, so now we can, so this is the x-axis and y-axis. So this is x-axis and this is y-axis, and then this is negative side of x-axis, this is negative side of y-axis, here origin. So now the job is that when we have this information, first we plot the the end behavior. So as we know, the graph goes downward as x goes to infinity. So firstly let me put here the 0. The zeros are here, negative 1 is a 0. So let me here put negative 1 and then 2 and negative 3. So this is the negative 3, put it here, and then we have the 0 are negative 1, negative 3 and 2. So 1, 2, this place. So this is the basically the graph, something like this. I mean the point or 0 of the function. So the zeros are we getting from the factor that x plus 1 and okay, let me write here the polynomial because we need it when we draw the graph. Fx equal to, we have x plus 1, the power is 1, and then x minus 2 whole square, then x plus 3 whole to the power 1. Now see, as we know the fx goes to infinity as x goes to infinity, so the right side behavior, if we look at here we have, so this means the graph will be some in the very far from origin, the graph will be, we don't know, roughly we are drawing like this, and then the left side is same thing happening. So I need little bit, so here, so this side also that goes like this, goes to infinity. Okay, so this goes to infinity, so upward. So and behavior, just we put it here that this way, here, so something like this. So this is x test. So both side and behavior we draw. Now what we have to draw here, we have to join this. Okay, let me put here y intersect also, whatever y intersect we have here. So we need that y intersect passing through the point 0, 12. So the 0, 12 point will be here, maybe this place. So this is, let me write 0, 12. This point is negative 3, this point is negative 1, and this point is 2. The graph will passing through negative 3, negative 1 and 2. And we can have at most 3 turning point. We cannot take more than 3 turn while we draw the graph. So let me join those now, keep that situation in mind. Now first we cross, we intersect x equal to 3. So see, one thing I tell you here, just a little bit recall the graph of let me take here, let me write here. So if you try to draw the graph of x equals to 1, y equal to x, then it is something like this. This is graph for x, the power is 1. Now if you try to draw graph of x plus x minus 1 or x plus 1. So thus this line you parallelly the shifted this situation. So this is 0, this is 1. So let's say along negative 1, so you have this. So this means, so this is graph of x plus 1 whole to the power 1. This is graph of x minus 1. Oh sorry, this is graph of x minus 1 whole to the power 1, because minus mean we shifted to the right hand side this graph, and this is left hand side. So this means basically if you have x plus 1 whole to the power is 1, I mean if you have power 1, then it is direct cross the x-axis at that point. So in general, if you have, let's say, x minus a, so it cross the graph at a point, x equal to a point, directly cross if you have x minus a whole to the power 1. Now what happened if you take x minus a whole square? So this means, for example, if you draw the x square graph, it will be a parabola. So this is 0, so vertex. Now in our case, if the vertex is a, so this means this is graph of x square. For x minus a whole square if you have, then graph will be something like this. Yeah, okay. So if you have power 2, then it is the round at the point x equal to a. If you have power 1, then it directly cross the x-axis. So keep this in mind. We let's say draw here it. So for this situation, we have factor x plus 3 whole to the power 1. So since we have 1, so it crossed the x-axis at negative 3 directly. Now what happened if you take x equal negative 1? So we have to directly cross here. So we must have take a turn at this point. We don't know the turning point, but there will be a turning point. So something like this. So this is a turning point. And we also know that it can have 3 turning point at most. So one we have used. So the rest we can take 2 turn. So now we have to reach this point because it intersect the y-axis. So it reach, and we have to make a turn because we have to reach the point 2. So now we move this direction. So now one important thing here, that you have x minus 2, that factor has power 2. So here you have to make a parabola. So you have to make a the round at that point like a parabola, and you go up and join this. So this is the total idea how to draw the graph of a polynomial. One thing I tell you, that when we are drawing the graph, we only keep in our mind 3 things, that the 0 of the polynomial, and number of and behavior, and number of turning point. How many turning point it is? It has, this is a turning point, this is a turning point, this is a turning point. So total turning point we have for this. So it is very much important that to check the graph is okay. Roughly the graph we draw, it is okay, it's okay, there is no issue. If you face problem that number of turning point more than 3, this kind of situation, but already 3 turning point can have, then you are drawing the graph is wrong. So you have to check, double check then. That's the idea. Now the if you want the accurate graph, so you have to use then more information from the calculus, like derivative, the saddle point, all the thing you have to use here, concave up, concave down, that we see in the calculus course. But here we are just doing pre-calculus, so this is enough. So this is the graph of the rational function, how you draw. So what we have done here, if you have polynomial fx, first what you do, since we have already the polynomial given, that polynomial was in the factor form, first you have to factor it. Then once you know the factor, then you go to the and behavior, right and left, and then x intersect, y intercept, turning point, how much turning point can it have maximum, that. So one example I tell you here, that you need to factor. So it is here that let me take here the polynomial. So this is example. So let we have a polynomial fx equal to x cube. So let's say x square plus 5x. So this is the polynomial. So how you do this, the graph of this polynomial? So what you have to do, first you have to factor it. So fx equal to x square plus 5x. So factor mean, you know what, you have to factor out some common factor from every term. So from here you can factor out x, then you get here x plus 5. So basically if you have a polynomial, if you want to factor it, you have to write down that polynomial into the smaller degree polynomial, the product of smaller degree polynomial. But it is not always possible, it become little bit hard, but you can do it. The problem you will get that you can factor. So this is one example. I just told you the factorization. After everything you can do. The next polynomial that I am taking, little bit challenging. So this is fx equal to x cube plus 6x square, little harder polynomial I am taking. So okay, so this is 5x square. So I am taking little bit complicated polynomial here. So just recalling, you know, something work on polynomial, the long division or synthetic division that we can use here. So this polynomial we have, but it is not in the factor form. First we find out the factor. So one thing, let me tell you, if you have a quadratic polynomial, you know how to factor it. You apply the AC method. For example, if you take here, let's say gx equal to x square plus 5x plus 6, using AC method you can calculate it, factorization. The middle term you can replace by 3x plus 2x, then plus 6, and then x you factor out x plus 3 plus 2 factor out, then x plus 3, then it is x plus 3 factor out, then you get x plus 2. This is the factorization. Now if you have this kind of degree 3 polynomial, in this situation it is little bit challenging, or I mean in this case you have to guess the 0 where you have 0. So I will suggest here something you can do for these zeros, that we can put here 0, 1, -1, 2, -2. You just put those integer on the polynomial, and you can see that from this list one of the number must be the 0. It is not in general, but in your case it will work. So for elementary it is works. So let me check for first example. So if we put here 0, so then what we are getting? You keep putting the value until you get 0 for the expression. So here getting -9, so this is not equal to 0. Put 1. What happened? If you put 1 cube plus 5 into 1 square into 3 into 1 minus 9. So basically you are getting 1 plus 5 plus 3 minus 9. So we are getting 0. So x equals to 1 is a 0 of this polynomial. Is a 0 of the polynomial fx. So what we get? So we get x minus 1 is a factor of fx. That is important. So now since it is a factor, just we find out the quotient. So you can calculate the quotient to different way. Let me use here synthetic division. So first we write down the coefficient of fx here. So 1, then 5, then 3, then minus 9. So firstly, if you have some term missing here, you put 0 that place. For example, since here you have x cube degree 3, then degree 2, degree 1, then constant. So every term appear here. So we not need to put here 0. Suppose you have here x cube and 3x minus 9, then you have to put 1, 0, 3 minus 9, like that. So once you have, then for this factor, so this 0 you have to put here. So now you know what, immediately you put here this 1. I just immediately put, then I multiple and then put it here. This is put here. So we getting 1 into 1 is 1. 5 and 1 you add. So if you add, then you get 6. Then again multiple this, then you get 1 into 6, 6. So if you add, then you get here 9. Then again multiple, so and put it here. So then you get 9, so 0. So the quotient will give you here, quotient is given by, quotient is basically x square plus 6x plus 9. So our polynomial, so fx, now we are getting it is what? x minus 1 into the quotient x square plus 6x plus 9. So then this is degree 2. If you factor, you can see it will be x plus 3 whole square. So this is the factor form. Once you have a factor form, you can draw the graph of this polynomial. First and behavior you check, the zero you check, and number of possible turning point, all the thing you can calculate, and as like this example, you can draw the graph. So the important thing, you have to first write down the factor form. I think this is enough for the polynomial. So graph of polynomial. The next video we see the graph of rational function, how to draw. Thank you.